Hello everyone, this is our third online lecture and I'm going to explain a new lesson which is chapter 15. We are going to talk about generalities about functions. Our objectives is we are going to define what's a function, how do we find the domain of definition of a given function. We are going to graph a function point by point. We are going to distinguish between even and odd functions and variations of a function. I'm going to start first. Look at this graph. This is a trajectory of a bat. Um, and on the axis of abscissa, we represent the distance x traveled in meters by the bat. And on the ordinate, the height in meters attained by this bat. So it's the variation of the distance traveled as a function of height in meters attained by this bat. Okay, let us look at this graph carefully. Can a line D, which is parallel to the ordinate axis, cut the curve in more than one point? So they are asking us, if I draw randomly any straight line which is parallel to the y axis, is it going to cut the graph in more than one point? I'm going to draw as a random this line. It cuts the graph only in one point. So you cannot find a line that cuts the graph in more than one point. We are going to talk about this later on. Let us pick from the graph the height, the height attained by the bat when it covers a distance of 25 meters. So when it cuts a distance of 25 meters, what's the height or what's the y? So for x equals 25, what's the y? The y is 4 meters. Now, if the x is 100 meters, what's the y? It's 6 meters. They asked us at what distance the bat reaches a height of 1 meter. So now we are given the y and we need to find the x. So when the y is 1 meters, what's the x? You follow the graph, it's 200. When the y is 2 meters, what's the x? It's around 170 meters. Now what's the maximum height and what's the minimum height reached by the bat? The maximum height is, as you see, is 6 meters, and the minimum height reached is 1 meters. Let us continue. Indicate on the axis the distance of distances, the intervals where it ascends or where it increases and where it decreases. Let us start first. Where does this graph increase? So it increased from 3 to 6, or from 0 to 100 meters. If you look at the axis of abscissa, you can see that from 0 to 100, this graph increased. It also increased somewhere else. It's from 200 to 275. Also, this graph increased. But from 100 till 200, this graph decreases or descends. While from 275 till 350, this graph is constant. So let us complete the following table by using the graph. So when the x was 0, the y is 3. It increased when the x becomes 100 and the y 6. Then it decreased. If you can see this arrow, it indicates that the graph decreases till 200 and the y is 1. Then it increased till 275 where the height is 4, and it remains constant as it continues. Okay? So, as a definition, we notice that for every x, there's a y. So for every x covered in meters, there's a height also covered. That's what we call a function. When there's a relation between the distance and the height, or between y and x, then this is a function. Where for every x, there's only one y, or one f of x. So the function f is a mapping of a part of R into R. It associates to every element x of I one and only one image by f, denoted by f of x or y. So starting from now on, instead of saying, for example, y equals 2x plus 3, we are going to say f of x, the function of x, is equal to 2x plus 5, for example. And for every element x, there is only one f of x or one y. We call it the image. Okay? So I is called the domain. I is all the set of elements of this function. And I is R. For every x, there is only one f of x or one y. This is the function. Okay, so it's a mapping where every element x, it has only one image. Okay? But how do I find the domain of definition of a function, or what's the meaning of domain of definition of a function? The domain of definition of a function is a part I of R. It's a part of the real numbers, such that every element of I has only one image by f. And this domain is sometimes given, but if not, we should find it. Okay? So I'm going to teach you how do we find the domain of definition. First of all, suppose we have the function f of x equals 3 over x minus 1. I told you, f of x means y. Instead of y, we are going to call it f of x, the function of x. If it was, for example, 3 over t minus 1, then it's f of t. So f of the variable that we have. If you look at the denominator, we have x minus 1. You know that the denominator should be different than 0. So x minus 1 is different than 0. So x is different than 1. That means x equals to 1 does not have an image by f, doesn't exist on the graph. And the domain of definition of f is every real number different from 1. So all the numbers are accepted except 1. So the domain is from minus infinity till 1, union from 1 to plus infinity. You are familiar with those intervals because we already learned before how do we find the interval of solution. We took this in the system of inequalities, we took this in the equations, we discussed all the conditions, right? So what's new is that when x equals to 1, it doesn't have any image in the function, so it's not defined. Okay, let us take an example. Suppose we have a function which is defined by f of x equals radical x minus 1. Before starting solving this, or before trying to find the domain of definition, if I replaced x by 2, so I'm trying to find f of 2, then it's radical 2 minus 1, which is radical 1, which is 1. And you know that 1 belongs to the real number. Then 2 belongs to the domain of definition of f. So suppose this function, it has a domain of definition. As long as this number, it exists in real numbers, then this number belongs to the domain. Okay? And we say that the function is defined at 2. What if we replaced, instead of x, 0? So I'm trying to find f of 0. So f of 0 equals radical 0 minus 1, which is radical minus 1, and radical minus 1 is impossible in R. So it doesn't belong to R. So 0 Absolutely, it doesn't belong to the domain of definition of this function. So we say that this function is not defined or undefined at 0. Later on, or starting from now, I'm going to teach you how do we find the domain of definition of a certain functions. And you have to know that we have only three conditions or three types of functions. It's either polynomial, it's radical, or rational. Okay, so you have to keep in mind that we have three conditions: polynomials, radicals, and rationals. I'm going to start first by polynomial. What if the function is a polynomial? And you know that it's a polynomial whenever you have a variable or the same variable but with different degrees. For example, f of x equals 3x to the power 4 minus 7x to the power 3 minus 3x plus 12. So the only variable is x, and x is to the power of degrees. Those degrees are numbers, are whole numbers. So since f of x is a polynomial, then the domain of definition is r or minus infinity plus infinity. So all the numbers are accepted. I don't have any condition to take here. All the numbers are accepted. Okay, whether it's positive, it's negative, I don't care, because all the numbers would give me a real image. Okay, so keep in mind the first function, which is the polynomial. Every time you see a polynomial, then the domain of definition is r or minus infinity plus infinity. Let f of x equals 2x cubed minus 3x squared. Then f of x is also polynomial, then the domain of definition is also r. Also g of x, which is minus 3x plus 6, it's a polynomial, then the domain of definition is also r. Now, what if we have a rational function or fraction? Okay, what you should do is to take the denominator different than 0. So we're going to take x minus 2 different than 0, then x is different than 2. Then the domain of definition in this case is all the real numbers except 2. So we write it minus infinity to union 2 plus infinity. And the interval on 2 is open because 2 is not accepted or not doesn't belong to my domain. So the first thing we learned is if it is a polynomial, then the domain of definition is r or minus infinity plus infinity. If it's a fraction, you have to take the denominator different than 0. How can I know that my answer is correct? Just replace 2 in the function. You are going to get 3 over a 0, which is impossible. So then f is not defined or it's undefined on 2. Also look at this fraction. It's a rational function, so it's a fraction. So we need to take the denominator different than 0, which is x squared minus 25 is different than 0. I factorize the function, which is x minus 5, x plus 5 different than 0. Then x is different than 5, and x is different than minus 5. So both of them, minus 5 and 5, they are excluded from my domain. So we write the domain of definition is minus infinity minus 5 union minus 5, 5 union 5 plus infinity. And it's just enough to replace 5. You can see that I'm not going to get a number that belongs to r, so f is not defined at 5. What if I have radical? So as I told you, the first function is a polynomial. The domain of definition is r, while if we have a fraction, we need to take the denominator different than 0. And if we have a radical, what should we do? We need to take everything inside the radical greater than or equal to 0, because you know that radicals are positive numbers. So I take everything inside the radical greater than or equal to 0. I solve the inequality. As you see, I'm going to get x greater than or equal 3 over 2. So the domain is from 3 over 2 till plus infinity. It's enough to replace 3 over 2. You are going to see that I get a 0 that belongs to r. That's why it's closed at 3 over 2. Then f is defined at 3 over 2, but any number which is greater than 3 over 2, it's not going to be accepted in my domain. If I have radical x, so I take everything inside the radical greater than or equal to 0, so the domain is 0 to plus infinity. Now what if I have a fraction and a radical, both of them? It's very easy. You know that you need to take the denominator different than 0, and you need to take the denominator positive. So it's enough to take everything inside the radical only greater than 0, and it's not equal to 0. It's only greater than 0 because it's in the denominator. It shouldn't be equal to 0. So I just take in this condition 2x minus 3 greater than 0. And as you see, I'm going to get the domain, which is 3 over 2 till plus infinity. And that's everything for the domain of definition. So just a quick revision. When I say domain of definition, I mean 3 conditions only, or 3 types. If it's polynomial, then the domain of definition is R. If it's fraction, you need to take the denominator different than 0. If it's radical, you need to take everything inside the radical greater than or equal to 0, unless if it's in the denominator, we only take it greater than 0. And now, let us continue for the third thing we are going to talk about in this video, which is the representative curve, or the drawing of the function. The plane is referred to a system OIJ, and let f be a function from a part I of R over real number. So as I told you, I, which is the domain, it's a part of the real numbers. And for every x, there is a function f of x. So the set of points M of the plane of the coordinates x, f of x, where x moves in I, is called the representative curve. So all the set of coordinates are called the representative curve of function. Since for every real x of I, its image f of x is unique, then every parallel to the y-axis cuts the curve at one point. I told you in the first slide that if you draw a line which is parallel to the y-axis, it should cut the curve only in one point. Else, this is not a function. So to make sure that this is a function, you should draw a line which is parallel to the y-axis. If it cuts the curve only in one point, then it's a function. But if you find a place where you can see that this line cuts the function in 2 points, then it's not a function. If you look at this curve, this is a curve C. So this is a curve or a function C. C represents a function. We draw this vertical line which is parallel to the y-axis. As you see, it cuts the circle, or it cuts the function only in one point. So we can say that C is a function. If you look at this curve, I can find only one line that cuts the curve into 2 points. In 2 points, it cuts the curve into 2 points. So that represents that this is not a function. This is not a function. Why? Because I can find a vertical line that cuts the curve in 2 points. So this is not a function. Look at this curve. This curve actually, it's the function f of x equals x squared. Okay, this is a function f of x equals x squared over the interval -2 plus 2. If you can see that the curve, it's from -2 till +2. Look at the axis of abscissa. The curve starts from -2 till +2. We say that this is a function because if you draw any line which is parallel to the y-axis, it cuts the curve only in one point. Okay, so from this graph, I'd be able to say if it's a function or not, and I can find the domain or the interval of this function. If you look at this curve, it's also it's f of x equals 4 minus x squared. Of course, you are not going to memorize them right now. Just look at the curve. The interval is from -3 till +3, as you can see, and it's a function because for every x, there's only one f of x. If you look at this circle, this is a curve C of a circle center O, 0, 0, and of radius 4 centimeter. It doesn't represent a function because, if you can see, for every x, there's 2f of x. Okay? Or in another word, for x equals 3, if you can see, there's 2.5 and minus 2.5. Or I can draw a line and it cuts the curve into two points. So we can say that the circle is not a function. So guys, if you want to check if it's a function or not, it's enough to draw a line which is parallel to the y-axis. If it cuts the curve in 2 points, then it's not a function. Okay? So till now we learned what's the meaning of a function and how do we find the domain of definition of a function. And using the curve, we will be able to check if it's a function or not, and we can also find the interval. And now we are going to learn something new, which is called the parity of the function and elements of symmetry. The parity of the function. When I say the word parity, I just need to know if this function is even or odd. And if it's even, what happens? And if it's odd, also what happens. Okay, so I'm going to start first by the even function. F, or f of x, or the function, is called an even function over D if and only if for all x belongs to D, then minus x also belongs to D. So if you replaced x by minus x, you are going to get the same function. So in order to know if a function is even, you have to find f of minus x. It should give you the same function, then it's an even function. And if it's an even function, then its element of symmetry is y prime or y is an axis of symmetry. So if it's an even function, then it has an axis of symmetry. We are going to take an example. Look at this curve, okay? This is the graph to the right is f of x equals x squared, okay? And I'm going to replace x by minus x. Minus x to the power 2 is the same as x to the power 2. So when we replace the x by minus x, I got the same function. So we can say that this function is even and it has, as you see, y prime y an axis of symmetry. So you can see that the y prime y is in the middle, exactly in the middle of the function. So everything to the left is symmetrical to everything to the right. Okay, so what did we learn? We learned that an even function, it has y prime or y, an axis of symmetry. And to prove that a function is even, you should replace x by minus x. You should get the same function. And you can take specific values. For example, if you replaced minus 2, you are going to get 4. And if you replace 2, you are going to get 4. Okay? Just to tell you something, you can find 2x for the same y, but you cannot find 2y to the same x. Someone got my idea, just tell me. I would give you bonus, okay, for this statement. Later on, I'm going to explain a lot of these, but repeat the sentence and tell me what did you understand. I'm going to continue anyway. Now, the first function, we said that it's even. Now we are going to learn about odd functions. So f is called an odd function over D if and only if f of minus x equals minus f of x. Okay? And then we are going to take an example. But first of all, if it's odd, then the center 0, which has coordinates 0, 0, O, it's the point of symmetry. So in even, we have axis of symmetry. In odd, we have point of symmetry. Look at this curve. It's obvious that they are symmetrical to each other with respect to a point which is 0. Okay? suppose we have the function f of x equals x cubed over 3. Okay, we are going now to replace the x by minus x. So it's minus x cubed over 3. Then multiply the function by minus, you are going to get x cubed over 3. Okay, so first of all, we replace the x by minus x. We got minus x cubed over 3, which is minus f of x. So it's an odd function. So f is a function defined over an interval I of r centered at 0. F is said to be even if f of minus x equals f of x, and it has y prime y and axis of symmetry. F is said to be odd if f of minus x equals minus f of x, and it has the origin O, a center of symmetry. Okay, so again, what did we learn till now? We learned what's the meaning of a function. We learned how to find the domain of definition of a function. We learned that if I have a curve, how can I know that it's a function, and how to know the interval covered in this curve. And we learned what's the meaning of even and odd function. So the parity of a function to know if it's even or odd. Okay? Remark, there exist functions which are neither even nor odd. So a function could be even, odd, or none. Neither even nor odd. So for example, f is defined over I, minus I is the domain. It's a part of the domain, minus 4 till plus 4, for the function x squared minus x. I is centered at I. It is centered at I, but it's not even, it's not odd. Look at that, because if we replaced minus x instead of x, it's not even and it's not odd. So it's neither even nor odd. Okay. Now the last thing I'm going to talk about in this video is the sense of variation of a function. We need to know the sense of variation of a function. Is it increasing? Is it decreasing? Is it constant? Is it increasing then decreasing? So when I talk about those, I'm talking about the sense of variation of a function. And as you know, we have three conditions. It's either increasing, it's either decreasing, or it's constant. So now we are going to see three curves, F, G, and H. I'm going to start first by F. As you look at this, F is increasing. Why? Because it's ascending from A to B. So this function is increasing. Look at, if you take any two coordinates, x1 and x2, okay? So I'm going to take any two abscissas, x1 and x2. X1, it has f of x1, and x2, it has f of x2, or y1, y2, okay? If you look at the figure, it's very obvious that x1 is less than x2. If f of x1 it's also less than f of x2, then the function increasing. While if you have x1 is less than x2, but g of x1 is greater than g of x2, then the function is decreasing. Okay, so again, take just any 2 points, x1 and x2. If f of x1 is less than f of x2, it's obvious that the function is increasing. But if g of x1 is greater than g of x2, then the function is decreasing. But if you have, if for every x1 and x2, h of x1 and h of x2 are equal, then the function is constant, or it's parallel to the x prime or x. Okay? Those were only explanation. So we say that f is said to be increasing if for x1 less than x2, we have f of x1 is less than or equal f of x2. F is said to be strictly increasing if for every x1 less than x2, we have f of x1 less than only f of x2. Okay, now there is another way to say if a function is increasing or decreasing or constant. We need to find a value t, which is f of x1 minus f of x2 over x1 minus x2. If this t is greater than or equal to 0, then f is increasing. If t is only greater than 0, it's strictly increasing. If t is less than or equal to 0, then it's decreasing. And if t is less than 0, sorry, it's strictly decreasing. If it's equal to 0, then f is constant. I'm going to take an example, and I'm going to solve them in two different methods, okay? And that would be the last thing I'm going to talk about in this lecture, okay? So we are going to take the first function, which is f of x equals 2x plus 5. I need to know if it's increasing or decreasing. So I should take two values, x1 and x2. So the first method, I'm going to take x1 and x2 such that x1 is less than x2. I'm going to replace x1 and x2 in the function. So I would get 2x1 plus 5, 2x2 plus 5. And now I'm going to subtract them. If the subtraction is negative, then f of x1 is less than f of x2. If the subtraction is positive, then g of x1 is greater than g of x2. Okay? So I'm subtracting f of x1 minus f of x2. So I got 2 into x1 minus x2 because the 5 are cancelled out. But you know that x1 minus x2 is negative. Why? Because x1 is less than x2 from the beginning. That was our condition. So that's negative, then f of x1 is less than f of x2. So f is strictly increasing over I. In the second method, as I told you, f of x1, you replace f of x1 minus f of x2 over x1 minus x2. After simplifying and so on, you are going to get 2, which is a positive number. 2 is a positive number, then f is strictly increasing over I. So you have two different methods. Either you find x1, you take a condition x1 and less than x2, and you discuss f of x1, f of x2. Either you do t, which is f of x1 minus f of x2 over x1 minus x2 to check if it's increasing or not. Another example, we have f of x equals 3 over x. In the first method, I'm going to take x1 and x2, x1 less than x2. I'm going to replace them in f of x1 and f of x2, and I'm going to subtract them to check their conditions. So we got that f of x1 is greater than f of x2, then f is strictly decreasing. In the second method, we got minus 3 over x1, x2. So it's negative, then f is strictly decreasing. And the last one, we have f of x equals to 4, and this is a constant function. And that was everything. So now we are able to determine the domain of definition of a function, to check from the graph the important things needed, to identify the parity of the function as even or odd, and to determine the sense of variation if it's increasing, decreasing, or constant.